right? Noble gases. In our baby no, baby means in our baby periodic table, group number 8 is for 3 elements. What were they? Helium, neon, argon. These 3 are called noble gases. Why? What is so special in them? This is it. Need your full attention, If you remember, first energy level, it is called K. Second energy level, which is called L. Third energy level, which is called M. Fourth energy level, okay, we don't need that one for the moment. In the first energy level, maximum, how many electrons are there? Maximum 1 or there can be 2. More electrons can't exist in this one. If electrons, they go to second shell. In the second shell, there can be how many electrons? 1, 2, 3, 4, 5, 6, 7. Maximum is 8. Okay. So, in second shell, maximum is 8. Maximum is 8. Third shell, 1, 2, 3, 4, 5, 6, 7. Usually 8 is there, but it has a space to keep up to 18. දැන් පරක්කු වෙන අය සද්ද කරන්නේ නැතුව හොරෙන් වාඩි වෙන්න ඕනේ. හරිද? හොරෙන් සද්ද නැතුව මට ඇහෙන්නේ නැති වෙන්න වාඩි වෙන්න ඕනේ. Right. 18. First shell 1 to maximum 2. Second shell 1 to maximum 8. Third shell 1 to maximum 8. In non-reacted normal atoms. Right. So, noble gases are the gases which have filled the valence shell, outermost shell with maximum number of electrons. They have completely filled the outermost shell with maximum number of electrons. Therefore, they are stable. Say they are happy. They don't want anything because the outermost shell is completely full. Right. Let's take helium. Helium has 2 protons in the nucleus, therefore 2 electrons also in the shell. Neon is the 10th element, if you remember. 2 in the first shell, 8 in the next shell. Argon 18, 2 in the first shell, 8 in the next shell, 8 in the last shell. So, these helium, neon, argon noble gases have a completely filled outermost shell, 288, 288. Therefore, these gases are inert. These gases are non-reactive. These gases are not going to react with other atoms of the same element or other atoms of other elements. No reactions. That is the specialty of noble gases. Now, I do not take time to give note on noble gases because we have 2 big things to do today. So, I introduce noble gases. I am not going to give any note, but it takes 3-4 minutes. Even 3-4 minutes important for us today, very important. Okay. So, with this knowledge, without completing anything, let us come to next part. So, but once again summary, what are noble gases? Helium, neon, argon, which have completely filled the outermost shell with maximum number of electrons. So what? So they do not react. Scientists identified some non-reactive gases in periodic table. They studied why. They found this outermost shell is completely filled with electrons. So they do not need anything else. They are stable, say they are happy, they are satisfied. They do not react with any other atom, noble gases. But when you check most of the other elements like hydrogen, sodium, potassium, calcium, magnesium, aluminum, sulfur, oxygen, anything, almost everything, they react with other atoms. If you study their electronic configuration, you can see valence shell is not completely filled. Valence shell has less than maximum number. If there is one shell, maximally there should be 2 electrons. No? If there are no 2 electrons, they react. In the second shell, there should be 8 no maximum. If there are no 8, less than 8, they react. Third shell, if there are no 8, they react. And after reacting, okay, they want to react, no, we allow them to react. After reacting, we take them and see valence shell now. Now valence shell is completely full of electrons. Okay. So, if valence shell is completely filled with electrons, they do not react. If valence shell is not completely filled with electrons, they react. After reacting, we check their valence shell. Now, it is completely full, completely filled. This knowledge you need to understand next part. Okay, first ionization energy. Right. Now, without giving any note on noble gases, it takes 2-3 minutes, but important for us, 2-3 minutes even. We skip noble gases note and we come to patterns in periodic table. So, help me to finish first 2 patterns today. Need your attention. Okay, very difficult 2 graphs we are going to do today, very difficult, but we are going to make it nothing, very simple today. We are going to make it very simple today, very simple today. Unfortunately, some are missing, many are missing. 2:30 ne? School is 2:30. So, we have to start class at 3. What to do? Right. Okay, forget about it. Let us focus on this. Patterns in periodic table. And this class also, you all, anyone in this world is going to get as a free lesson. I am going to upload this one. You know why? Because of last event in Kandy, many students miss our classes, and I have done this class in other institutes those days. Therefore, I have to upload this so that anyone can join. You also can join again, right? It's good. It's a difficult one, right? Patterns in periodic table, page 7. Ready? So, what these patterns in periodic table means? Patterns in periodic table means, if I quickly write periodic table, our baby periodic table. Okay, let me write here. Right. Okay. If we take this periodic table, you know these vertical columns are called what? Groups. Horizontal rows are called what? Still I am marking groups. Group 1 to 8. These horizontal rows are called what? Periods. First period, hydrogen and helium. Second period, lithium, beryllium, boron, carbon, oxygen, fluorine, neon. Third period, these elements, and fourth period these, you know. Now, patterns in the periodic table means, focus well, when we are going from left to right, from hydrogen to helium in period 1, from lithium to neon in period 2, sodium, magnesium, aluminum, silicon, that way to argon in period 3, even in period 4, potassium to calcium. When we are going from left to right along a period, certain properties, certain features of these elements change. There are only 4 features in our O-level syllabus, like first ionization energy, electronegativity, metallic properties, basic acidic properties of oxides. Hurry. When we are going from left hand side corner to right hand side along any period, 4 properties change. 4 properties change in a particular way. When we are going from left to right in the next period also, same way they are changing. Okay? Say we go from left to right from lithium to neon one by one. Those 4 properties change. Some of them increase, some of them decrease, some of them change in a complex way. Same way they change when we go from sodium to argon also. Therefore, it becomes a pattern. It becomes a cone pattern. Why? In group, in period 1 also same, in period 2 also same, 3 also same, 4 also same, they are variation. So, then it becomes a pattern, isn't it? Should explain in Sinhala? I do not think so, right. So, when we are going from left to right one by one along a period, certain properties change. Same way they change in the next one also, next one also, next one also. Then we can call it a pattern. Okay? Those features, those properties change opposite way when we go from top to bottom down a group. First we went from where to where? Left to right along a period. Now when we are going from top to bottom, down top to bottom, top to bottom, down a group also. Those properties change. Which way? Opposite way. Opposite way means, say something was increasing from period 1, period 2's lithium to neon. Say something was increasing. Same thing increases here also, sodium to argon. That thing now decreases from top to bottom, hydrogen to lithium, lithium to sodium, sodium to potassium. That property, that feature is decreasing now. So left to right was what? Say increasing, now decreasing. Say left to right something was decreasing. Now top to bottom same thing is increasing. Interesting. So remember how they change from left to right only, then you know top to bottom is opposite. Okay? Right. So throughout this lesson we discuss this. What? When we are going from left to right along a period, when we are going from top to bottom down a group, this way they change. Okay, then let's go and see which way what change. හරිද? අපි periodic table එකේ වම් කෙළවරේ ඉඳලා දකුණු කෙළවරට යනකොට period එකක් දිගේ එක්තරා properties වගේක් change වෙනවා. ඒ විදිහටම ඊළඟ එකෙත් වෙනවා. ඊළඟ එකෙත් වෙනවා. ඊළඟ එකෙත් වෙනවා. හරි? උඩින්දලා පල්ලෙහාට ගියොත් ඒ property එක අනික් පැත්තට වෙනස් වෙනවා විරුද්ධ විදිහට. වැඩි වේගෙන ගියා නම් දැන් අඩු වෙනවා. Okay. Right. Described in signal also the first one. Right. Now patterns in the periodic table. Pattern means what? Again and again, again and again, again and again. That variation can be seen. Right. Patterns in periodic table. Physical and chemical properties of elements. What? Physical and chemical properties of elements. These elements vary in a systematic pattern from left to right and from top to bottom in periods and groups. Left to right variation is opposite to that of top to bottom. Got it? Right. Now what are we going to study here for O levels? First, ionization energy, electronegativity, metallic properties, acidic, basic, amphoteric properties of oxides of elements. One last time. First ionization energy, something called first ionization energy, which way changing. I have to introduce first ionization energy is what first ne? Next one, something called electronegativity changing which way, left to right and top to bottom. Third one, metallic properties change which way, that you know. You know in this periodic table left hand side are what? Metals, right hand side are what here? Non-metals. So metallic properties decrease, non-metallic properties increase because metals are here, non-metals are there, that you know. So we don't need much time for that. Okay. Last one also is new. What is it? Acidic, basic, amphoteric. Amphoteric means both acidic and basic of oxides. Right. Today our target is 1 and 2. We need long time for this. Right. So I am going to introduce you what first ionization energy is. Don't read. Don't read. Right. There are two ways. One way is to describe, second way is to give the note. Okay. There is a way to describe, there is a way to give the note. So note I have given, now is describing type. Okay. So don't read it, take this into your head. You learn now, remember now, record now, finish now. Welcome. හරියටම හරි වෙලාවට ඔය ආවේ වඩියෙන්. හරි දැන් හුස්ම ගන්නවත් බෑ අහන් ඉන්න ඕනේ. You can't breathe even. Listen carefully. Okay, going to start something very difficult. First ionization energy. You know the meaning of first. There are many first thing in the life. First this, first that. No? There are many first thing in life. First this, first that. There is something called first ionization energy also. First something. Okay. So there is something called first ionization energy. First means number one, first time. Ionization means what? Energy means what? Energy you know. Only middle word you don't know. First you know, energy you know, ionization you don't know. Listen carefully. Ionization means formation of ions. Ions means yakada, not yakada. These ions are IONS ions. Okay, yakada is IRON ion, no, this ion is ION. So, ionization means formation of IONS. What are ions? Right. Ions are when atoms either remove electrons or receive electrons. What? Atoms remove electrons, atoms receive electrons. Yes, maybe the first time you learn this. And this is in grade 10, unit 10. What is grade 10, unit 10? Chemical bonds. When atoms remove electrons or take electrons, they form chemical bonds. It is unit 10. But we can't go quickly to 10 and come here. Ne? We have to go to 10 and come here very quickly. Right? Okay. Ionization. What is ionization? Formation of charged atoms by removing electrons or taking electrons. Why is it necessary for atoms to remove electrons or take electrons? Right. I told you that most of the atoms are reactive and most of the atoms react. Why? They are not like noble gases. Their outermost shell is not completely filled, therefore they react. After reacting, they fill their outermost shell. Okay, let's take one example. Right, let's take, now we are going to go from left hand side to right hand side now. Let's just start from left hand side, long period, this one and this one. Okay, let's take lithium. Listen carefully. Right, lithium. This lithium, what is the atomic number of lithium? 1, 2, 3. Atomic number is 3. What is the meaning of atomic number 3? 3 protons are there and 3 electrons are there. We need, this is what we need, 3 electrons. These 3 electrons exist as, tell me, first electron which shell? First electron, first shell. Second electron, first shell. Third electron, second shell. Yes, because first shell can keep only 2. So, lithium is this. Is its outermost shell full? No. It needs how many to fill this? 7. Yes. Very difficult to find 7 electrons. It feels very easy of giving this electron out. Because of this electron, it is not stable. So, it removes this electron. Then its configuration is similar to that of what? That of what? Coconut. That of what? Helium. Look at that. Helium is 2. So, if we can remove this electron, it can become easily similar to helium in configuration and stable. Got it? If it wants to fill, how many electrons to be found? 7. Not that easy. Giving one is easy. So, it tends to give this electron. This is ionization. After that, lithium becomes lithium 2. But it can't be lithium, no. This was Li, this also Li, can't be. Now, we call this Li plus. This is called lithium ion. Why is it plus? Okay, you can understand this way. Lithium has 3 protons. 3 protons means charge is positive 3. 3 electrons. 3 electrons means charge is negative also 3. What is the total charge now? 0. Atoms are like that. Neutral in charge. Why? Electrons and protons are equal. Now what? Now what? How many protons? Protons can't go anywhere. Protons can't go anywhere. Electrons can go. And 1 electron went. How many electrons now? 2 electrons. What is the charge? Negative 2. Now positive 3, positive 3, negative 2. What's the charge? Simple maths. Positive 3 and negative 2. What is left without getting utilized? 1. Which one? Positive 1. Right, positive 1. Therefore, we write it as Li positive. We don't write 1 here. Once we write positive sign, that's enough. No need to write 1. Eh? Positive 1, negative 1. 1 we don't write, just we put positive or negative. This is called lithium ion. Now you know what is lithium ion. Now its electronic configuration is equal to that of helium, stable. It's not going to change. This way, lithium ionizes. Sodium also. Sodium also means sodium is 11. What's the configuration of sodium? Right, let's take sodium here. Sodium is 11. What is the electronic configuration? 2, 8, 1. You can understand. Same way, this electron it's going to donate. And after donating electron, what is the charge gained by it? Simple. Because of giving one electron, charge coming is exactly like that. Charge coming is positive 1. So, this way sodium becomes 2,8 and then it is sodium plus ion. This is first ionization of sodium. It is equal to neon in configuration now. Got it? Potassium also. Potassium is our 19th one, 2,8,8,1. What's wrong? This one. What's the solution? Donation. Removing this out. Hurry. What will be left? 2,8,8. It is similar to argon in configuration now. And what forms? K positive ion. This is first ionization of potassium. This way now you can understand that atoms do first ionization to become stable. Okay. So, what is ionization? Atoms removing electrons to acquire a stable electronic configuration. Okay. Right. Don't look at him, not an atom, not an ion, one of your friends. Come in. ඒ පැත්ත බලන්න එපා, attention එක නැති වෙනවා. Right. Okay, I also lost my attention. Okay, this is ionization. So, what is ionization? Removal of electrons to form positive ions. First ionization is that. Okay. So, these atoms also can remove electrons this way. Example, if you take magnesium, what is the configuration of magnesium? Magnesium is 12, 2,8,2. Tell me, magnesium has to remove how many electrons to become stable? 2 electrons. If both electrons can be removed, it can become 2,8. Then it is similar to neon in electronic configuration. First ionization is not enough now, isn't it? There should be second ionization also. So, magnesium has first ionization, then second ionization also, but we are talking about here only first ionization energy, right. That is one ionization, removal of electrons. There is another one ionization. We do not take that one here. Okay, let us take one example, chlorine. Chlorines, camera chlorine's atomic number is 17, 2,8,7 is the configuration. How can it fill the outermost shell? By removing 7? No, it can find one. Why? These ones are removing electrons, no? Removing electrons easily. One of those electrons can be taken by chlorine. That way also they form ions. One electron is taken. Then it can acquire 2,8,8 electronic configuration, which is the configuration of argon. That also is ionization. This makes a negative ion. Why negative ion? Because of losing one electron, charge becomes positive 1. Because of taking one electron, neutral one becomes negative 1, because electron is negative. Because of losing electron, electrons, protons are not balanced now, it is positive. Because of taking, it becomes negative. Therefore, chlorine forms chloride ion. Later, this also is ionization. Right. Now, first ionization is okay. First time when they remove one electron to become stable, we can call it first ionization. What is first ionization? Energy. Last word. මොකද්ද මේ energy කියන්නේ? First ionization. Okay, energy. First ionization energy. Okay. Let's draw rough sketch of lithium atom to understand this one. First ionization energy. Okay, I am going to draw here lithium. Lithium atom has how many electrons? 3 electrons. One electron in the first shell, next electron in the second shell, and next electron in the third shell. Right. This is our beautiful, lovely lithium atom. Right? Protons are there in the nucleus. How many protons are there? 3 protons. Right. I write here 3 positive charges. 3 protons means 3 positive charges. Now, to understand our concept much more easily, I am going to remove inner shells electrons. Why inner shells electrons? චූට්ටක් නිදිමතයිනේ. බොරු නම් කියන්න එපා නෑ කියලා. අපි නම් නිදිමතයිනේ. හරි. Okay. Let's remove this one to understand our concept much easily. Now lithium is going to remove this electron. Why? Lithium wants to become stable. But even though lithium wants to remove this electron, its protons don't want this electron to go. Why? Protons are positively charged. Electron is negatively charged. You know, always between positive and negative there are what? Attractions. So this way there are attractions between this electron and protons in the nucleus. Because of this electron can't go out easily. Got it? Because electrons and protons attract each other. Therefore this electron can't go easily. If we want to send this electron out, if this electron wants to go, we have to give some energy to break these attractions, and this energy is called ionization energy. Harida, we have to give energy. I write here, we have to supply energy. We have to supply energy to break these attractions to remove the electron out. Got it? There are attractions, no? To break attractions, we have to give something. Can we give money? Atoms don't need money. Atoms, these electrons need some energy. By giving energy, we can make this electron energetic, and it breaks this attraction and it goes out. This energy is called first ionization energy. Got it? So first ionization energy definition is this. The minimum amount of energy should be supplied to an atom. Once again, take into your head now, the minimum amount of energy to be supplied should be supplied to an atom. What for? To dance? Not to dance. Then to remove one electron from the valence shell to form a plus one unipositive ion. One last time. What is first ionization energy? The minimum amount of energy. Minimum amount of energy should be supplied for an atom to remove one electron from the valence shell to form a unipositive ion ion. Got it? This is called first ionization energy. Prathama ayanikarana shakti. What? No, first ionization energy. Got it? If you give first ionization energy, atom will, or that electron will take energy, will break the attraction and will go. First ionization happens. But scientists say first ionization energy for a single electron, single atom is extremely small. So when we express this amount, we don't do it for one atom or one electron. We find it for this number of atoms. 6022? No. I have to put zeros here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more years. 11, 12, 13, 14, 15. Not over? No. Shall I start here? 16, 17, 18, 19, 20. Oh my God. We find first ionization energy for this number of atoms. This is called in your unit 7 Avogadro number of atoms, or 1 mole of atoms, 1 mole of atoms, or this number of atoms. Okay. So first ionization energy is calculated for this number of atoms, 1 mole of atoms, and energy is measured in joules. And when energy is like 1000 joules, we can call it 1 kilojoule. Like 1000 grams kilogram, 1000 meters kilometer, 1000 joules kilojoules. So first ionization energy is expressed in simple K, capital J, kilojoules for how many atoms? That number of atoms, 1 mole of atoms. This is not kajumole neveya, kilojoules per mole, kilojoules per mole. That means how many kilojoules for that number of atoms. Okay. So now you know what is first ionization energy, why is energy necessary for ionization, and its unit is kJ mol minus 1. Okay, right. So before drawing graph, you should understand what is ionization and what is first ionization and what is this energy. Right. Let's read it, but before that we once again discuss what is first ionization energy. What's the first word? What's the second word? Minimum. Again you come to this front row stuck ගලවලට යනවානේ. ඒගොල්ලෝම කියනවා. ලේසියෙන්ම ඒකක් ගන්න පුළුවන් ඉස්සරහට ආවයිද? හරි. අනිත් අය පුළුවන් ඉතින් පොඩ්ඩක් අමාරුයි. Right. What is it? The minimum amount of energy to be supplied for an atom to remove an electron from the valence shell to form a unipositive ion ion. That's the meaning. Okay, right. Now we read and complete this first ionization energy. Okay, ready? Page number 7, our tune. Take it. Let's read quickly. First ionization energy. Ionization is, when we write ionization, we write SA, sometimes we write ZA also. Ionization, 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 ionization. Oh my God. Please pass these tubes. I have some extra copies. Okay, complete. Right. Okay. Ionization is number 1, removing electrons from valence shell, that means outermost shell, to produce positive ions called cations. It is 1. Second one, accepting, receiving, gaining electrons to valence shell to form negative ions called anions, like chlorine. Okay, right. Then electrons in the valence shell are attracted by positive charges, protons in the nucleus. Therefore, to remove electrons from the last shell, we should supply some energy to overcome those attractions. I described this story. Minimum energy that should be supplied to an atom to remove an electron out from its valence shell is called first ionization energy. Element should be in the gaseous state. I didn't talk about this, no? So remember, it's nothing. When we find this, the element should be at gaseous state, not solid state, not liquid, gaseous. So all the values you study, you see here are when elements were at gaseous state. Okay, you don't need it, won't come that one. What is the physical state? Right. Now first ionization energy is minimum energy that should be, what's the next word? That should be supplied, right, supplied. The minimum energy that should be supplied, right, then to an atom in the gaseous state, gaseous, gaseous state. Don't write gaseous state, it is called gaseous, gaseous state, gaseous state. Okay, right. Now once again, minimum energy that should be supplied to an atom in the gaseous state to what? To blank electron to remove, right there, remove, to remove an electron to form a unipositive gaseous ion. Unipositive means 1 plus. Gaseous ion means physical state is gas, right. Now lithium's first ionization we should write, but I skip this part also. Why? Today we should finish this one and we should finish next graph also. Writing part is nothing, right? Understood now what is ionization? Enough. Right. Now we come to page 8. First ionization energy is measured for 6.022 into 10 to the power 23 atoms, 1 mole of atoms. Now you don't think that it is 6 point something, is extremely large value, that value. Unit 7. So you want unit 7 to come soon. Don't wish so. It's going to kill you, but we are going to kill it. Don't worry. Unit 7 is going to kill you, but before that we are going to kill unit 7. Can. One of the most difficult ones, but nothing. Don't worry. Be simple. Hurry. 1 mole of atoms. Then, because it is very small, because it is a very small value for a single atom, that's why we calculate for that number of atoms. It is expressed in kjmol minus 1. What is this? Kajumol, not kajumol, kilojoules per mole. Mole means that number of atoms. We will call it Avogadro number of atoms also. 12 is called what? Dozen, isn't it? Like that number is called mole. Simple. 12ක් තිබ්බහම දුසිමක් කියන්නේ නේ. ඒ වගේ ආන් අච්චරක් තිබ්බහම MOLE එකක් කියනවා. බය වෙන්න එපා. Right. Now the most difficult one. Now the most difficult one. First ionization energy varies according to a pattern. We are going from left hand side corner towards right hand side corner. වම් පැත්ත ඉඳලා දකුණට යන්නේ. Left to right and top to bottom. Right. So first ionization energy varies according to a pattern. Let's try to get this pattern using not the graph, using the table. Look at the table. Oh my God, there are many values. Should we remember all these values? No, not a single even. But we use it, we understand it. Then we cut and remove this table. Okay? We use these values, we understand what's going on. Then we cut this table and we are never going to memorize these values. This is just to understand. Okay? So first of all, you can take your pencil and cut and remove this table by one line. Why do we cut? Because we are not going to memorize. That's why. Take your pencil, pencil පෑන ගන්න එක ඉරකින් සතුරු සිතෙන් කපලා අයින් කරා. Right? My pleasure, with pleasure කියලා කපලා අයින් කරා. Table only, not the graph. Have you cut and remove the graph also? No, not the graph. Only table. Are you okay there? Hello. Right. Can you see board? Okay. Ready? Right. Let's try to understand the pattern. First period, hydrogen. What is the value? 1370 or 10. 1310 or 1370. Just what you see. Okay, say 1300. Right. Helium 2300 something. No. So what can you say about the value? Value is higher. So left to right, what happens to first ionization energy? Increases. So our pattern is left to right, first ionization energy increases. Let's go and see second one. Lithium 500 something, 519, right? Beryllium 800 something, 897. What's going on? Increasing. Third one, boron 799, not increasing. No. Yeah, there is a drop. There is a drop. But next one, check next one. 1085, increasing again. Next one, 1406, increasing. Oxygen 1300, again there is a drop. But next one will be higher than that once again. 1600 and neon 2000 something, 2080. So you can see increasing, but there are two drops also. So it's like some steps. Increasing and there are two drops. Okay. So there's a pattern. Left to right increasing, but not continuously. There are two drops. So we can't say left to right increasing continuously. We say left to right increasing regularly. Increasing, again decreasing, again increasing, again decreasing, again increasing, increasing regularly. Let's go to third period and see whether same thing is happening. Sodium 495, magnesium higher than that. Exactly like second period, in the third period also, once again there is a drop, 577. After that, 786 increasing, 1018 increasing, exactly like last time. Sixth one, again there is a down drop, exactly like previous one. So that means there is a pattern. Ne? There's a pattern. It's common for second period also, third period also. Again chlorine higher, argon much higher. So again you can see same pattern. So this is the pattern. What's the pattern? Left to right, first ionization energy increases regularly. දෙමුතු අද පොඩ්ඩක් හොඳට චෙක් කරන්න ඕන කැමරා එක මයික් එක ඈ. හරිම අමාරු පාඩමක් කියන්නේ. සද්ද නැත්තම් ඉවරයි කට්ටිය. Yes, online friends, if you have any sound related, visual related issue, you can WhatsApp me, you can contact me, you know my number, it's in the tube. At least we can correct later, ne? Later we can do something, no? Right. Then that's the pattern. Potassium to calcium, 418, 590, increasing or not? Increasing. So you got the pattern. What's the pattern? When we go from left to right along a period, first ionization energy increases regularly, not continuously, but increases regularly. Remember? Right. What happens left to right? Increases regularly. If increasing from left to right, tell me what must happen from top to bottom. I said it's opposite. That means first ionization energy should decrease, top to bottom. Should decrease. Hydrogen to lithium, lithium to sodium, sodium to potassium should be decreasing. Let's go and check. Hydrogen how much? 1310 or 70. Can't see exactly. Lithium, oh my god, 519. Sodium 495. Potassium 418. Decreasing, right? Decreasing. Let's take second group. 897, 738, 590, decreasing. Let's take something from middle, fourth one. Nitrogen phosphorus, fifth one, nitrogen phosphorus, 1406, 1018, decreasing. Let's take last one, helium neon argon, 2372, 2080, 1521, obviously decreasing. So what is the pattern? Left to right increases regularly, top to bottom decreases. Got it? The very first thing is you should remember this pattern. Before graph inwards, left to right increases, top to bottom decreases. You remember one, left to right what? Top to bottom is opposite. Otherwise after few days, you know one is increasing, one is decreasing. Can't remember which one is increasing, left to right or top to bottom. It can happen, so try to remember one. Right. Now, got it, no? You cut and remove this one, no? Yes. Now what is below this graph, below this table? First ionization energy values of the elements with atomic numbers, right, ne? Okay. There are 4 questions to answer, then we come to our graph, the most difficult graph. 50 minutes went. Graphs දෙකක් අඳින්න තියෙනවා. බලමු. Along period from left to right, along period from left to right. What can you say? Along period from left to right, right? Increases regularly. Increases regularly. Come on, let's write. Increases regularly. The word increases will be enough, but let's write increases regularly. Came little late, ne? Okay. Don't try to get the concept, get the pattern. Now there is something called first ionization energy is changing. Which way? Left to right, increasing. Top to bottom, decreasing. Later you can try to understand what is first ionization energy, right? Say that thing increasing, decreasing, right? Second one, down a group from top to bottom. Yes, decreases, decreases. Third one, highest value is shown by the group. Give me an answer from 1 to 8. What is it? 1 to 8 වලින් උත්තරයක් දෙන්න. 1 2 3 4 5 6 7 8. Yes, highest value is shown by group 8. Helium, neon, argon 8. Right? Right, 8. That's what I expected. You can't write your normal 8, you should write Roman 8. VIII. That way you write 8 group numbers. How the group numbers ලියන විදිහක් තියෙනවනේ. There's a way to write. Roman 8. Lowest value is shown by the group. What is the number? 1 to 8. It is 1 because increasing from left to right. So, left is the lowest, right is the highest, right. So, these 4 questions answers you should know obviously. 1 group 1 answer is group 1 Roman 1 right. So, now we come to this graph. This graph you and me we are going to draw here. Why draw? You don't have part 2 of this. If you had part 2, it's really nice because you can go through past paper section and see. Mostly in a structured essay paper they are giving these graphs. Structured essay means you can't escape. Either you have to take marks from that or they take your marks. Got it? Structured essay, how many marks? About 7.5 marks. If you don't take, they take your marks. Right? It's very serious. Structured essay paper එකේ තමයි ගොඩක් එන්නේ. එක්කෝ අපි ලකුණු ගන්න ඕන නැත්නම් අපේ ලකුණු ටික ඒගොල්ලෝ ගන්නවා. Got it? Right. So they are not going to give the whole graph, full graph. They give parts of this main graph here and there. If you know the full graph, you can identify which part has been taken by them. Got it? If you know the full graph, you can find out which part is there given. If you don't know full graph, very difficult to find. Like say you are walking on the road and you can see particular human body part has fallen down. If you know all the, can't understand, singling here, පාරේ ඇවිදගෙන යද්දී මනුෂ්‍ය අවයවයක් වැටිලා තියෙනවා මොකක් හරි. ආයි පාර තේරුණානේ. Human body organ fallen down. Now, if you know all the body parts of humans, you can recognize from where fallen down, fell down. කොහෙන්ද වැටුණා කියලා හොයාගත්තේ. Otherwise, can you find? No, you can't find. Got it? Right? So, if you know all the body parts, then you can find. Okay, from that place. Right? Got it? Like that. If you know this graph fully, no matter which part is given, you can find it. You can match it. You know which part. Okay? Right. That's why we draw graph fully, you and me. Why together? We can draw this and practice now. It's very difficult to draw this graph without the steps, without shortcuts. So, let's find some shortcuts. Let's find a way to draw this one. Okay? It will be very helpful for you also and anyone watching this video also. Anyone can watch this one. No, I told you. Will be very helpful for all, right? So, let's draw that one. When we draw this, we need this grid like thing. O-level paper will not give you graph papers, will not give you square ruled papers also, will be normal single ruled paper. It's very difficult to draw this one there. We need vertical lines to mark these elements right above the atomic number. When you mark these elements, they should be exactly right above the correct atomic number. Nitrogen should be marked above 7. Say 7 is here, you mark nitrogen there. Wrong, no. You have to mark nitrogen here. Okay. Say sodium 11. You have to mark sodium here. So, we need some vertical lines. So, I want you to take your ruler and draw. What are you going to draw? Still I didn't say what to draw. Right? මන්දාම අනින්න කිව්වෙත් නෑ රූල අතරන ලෑස්ති වුණානේ හදිස්සි වෙන්න එපා I am going to draw with you. You have to draw first, listen 20 wait 20 vertical lines to mark 1 to 20 elements. Okay, then take your eraser, erase this way, then vertical solid lines will be vertical dotted lines. Don't draw dot again dot. Don't do it 20 times, right? Say there are 10 dots, 10 into 20, 200 times. Don't draw, just draw 20 and erase and make dotted lines with me, right? How many elements to be marked here? How many elements to be shown here? Our O-level baby periodic table is giving us 20. So, we have to mark 20 elements. That's why we need 20 vertical lines. Okay, let's draw together. You can use this printed graph as a help. You can see that also. And let's draw. When you draw, take the bottommost line as the x axis and this corner to draw the y axis. Otherwise, you won't get enough space to mark 20 elements. Okay, right. පල්ලෙහාම line එක ගන්න x axis විදියට වම් පැත්තේ කෙළවරෙන්ම අඳින්න y axis එක. මගෙත් එක්කම කරමු ඈ. Right. For me it's very difficult, but for you it's simple. You are sitting and drawing, I am standing and drawing. You have rulers, I don't. But maybe I have little practice than you. That's the most important thing. Okay. Y axis. Then we draw x. Right, let's draw x. Marker pen is crying. It knows how difficult first ionization energy graph is. Don't worry, after drawing this, you all will be able to draw this in very few minutes correctly. Okay? You have to practice, huh? You have to practice with me. Follow me. Don't follow your friend, follow me. Draw y axis, draw x axis. Right. On x axis, how many numbers to be there? 20. Don't put 0. There are no elements. There is no element with atomic number 0. Okay. Now look at this. Look at this. Using your ruler, you have to mark 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 20 marks for elements. They should be equal in gaps. හරිද? රූල් එක අරගෙන සමාන gaps තියලා marks 20ක් දාගන්න. Can you take 20 centimeters for that? Is 20 centimeters okay? How many centimeters? More than 20? 16 centimeters. Then don't take 1 centimeter. Somehow mark. Okay? Right. This way. Gaps should be equal, otherwise your graph won't get the correct shape. Right. Put numbers. Please work little fast. Halfway we can't stop electronegativity today. We have to finish that also. Electronegativity බාගෙන නවත්තන්නත් බෑ. ඒකත් කරන්න වෙලාව තියෙන්න ඕන. පොඩ්ඩක් ස්පීඩ් කරන්න. Right. 8, 9, 10. You know, I described it slowly. Now we are working little fast. 13, 14, 15, 16, 17. When your friends say after exam, your graph was very difficult, you can say graph was nothing. Was there a graph? Nothing for us. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Right. This way, there should be up to 20. Oh, sorry. From this end can't see. Okay, now, girls here. Corner. Come on, look at me. Can you see this 20? Okay. Right. Now let's write here. First ionization energy. First ionization energy. Please write these. First ionization energy. Inside brackets K, J, M, O, L minus 1. Can we mark first ionization energy values very correctly? It's very difficult. It's very difficult to mark 20 elements correctly. So, mostly you are going to get y-axis without values. Okay? Y-axis you will get without numbers. Why? It's very difficult to mark these values even without a graph paper, and we are not going to get like 10-15 marks for this. We are going to get few marks. So, they won't expect you to write these values. So, don't worry about those values. If you really can, you try, otherwise don't worry about that. Okay. මැරෙන්න යන්න එපා. ওই values ටික පාඩම් කරගෙන y axis එකේ ඕන වෙන එකක් නැහැ. x axis ඕනේ. Right. Don't put 0. No element with atomic number 0. Right. Now, see, you have to mark vertical lines, 20 vertical lines, erase and make them dotted lines. Don't try to draw dotted lines like I do. It's difficult for you. For you, drawing solid lines and erasing is much easy. හරිද? මම වගේ මෙහෙම dotted line නැදාන මැරෙන්න එපා. ඒක ඔයාලට වෙලා යනවා. මම ඉතින් පොඩ්ඩක් practice නේ හයියෙන් අඳින්නම්. ඕගොල්ලෝ solid lines ඇඳලා erase කරන්න. Right. Don't cry if you don't have a pencil. Take your pen and draw. And please join our WhatsApp group. Yesterday I think I reminded you to come today and to bring pencil, eraser, ruler, I have finished. Have you? Come on, fast. Still marking atomic numbers 120. No, fast. Come on. Vertical lines, quickly. ඉක්මනට අඳින්න. කෙලින් අතර තියෙන ඉර ටික fast. Right, nice. As a homework, you can erase these solid lines and make dotted lines, no? Right? Even you can leave, but with solid lines, your graph line will not be very clear. That's why I wanted you to erase. Right. Okay, come on. Only 1 hour more, less than 1 hour. Today it takes some time, long time, but exam day it will be nothing. So after this, you have to practice this 2-3 times, right? You all will know how to draw it, but increasing the speed is up to you to increase it. Got it? You should get your speed by practicing several times. ඔක්කොටම අඳින්න පුළුවන් වෙයි මේකෙන් පස්සේ. හැබැයි කොච්චර හයියෙන් අඳිනවද කියන එක ඕගොල්ලෝ හදා ගන්න ඕනේ. පොඩ්ඩක් මෙරිලා. Can't give more time. Right, let's just stop. Look at this now. Please keep your pens, pencils, you all away. Keep it. I'm going to take care. I'm going to come and take care. Practically impossible, but I can do if I can fly, ne? Right, hurry, pencil diyan. Right, bye, all, everyone. Right, okay. Let's draw in the mind, then take on to the dot. Got it? Right, anyone else? හොරින්වත් ලියන්න බෑ. ඔලුවට ගන්න ඕනේ. ගන්න දේවල් ටිකක් තියෙනවා. I told you no. There's a way to draw, there's a way to write, and there's a way to put into your head also. Right? So I am putting into your head now. Don't try to take on to the tute now. තේරුණාද? ඔලුවට දාන්න වෙන විදිහක් තියෙනවා, නෝට් එක දෙන්න තව විදිහක් තියෙනවා. දැන් ඔලුවට දාන්න යන්නේ. දැන් නෝට් එක ගන්න එපා. Got it? Right. So I told you that there's a pattern here. And that pattern is this. That pattern is this. This is like the structural unit of this graph. This is the heart of the graph. This comes how many times here? Find. You find. Otherwise you would say, no, so taught us and we couldn't understand, we can't remember. No, you find. I help you. You find. How many times you see this shape? 2 times. 2 times. And every time there is a similar pattern. What is it? You find and tell me, this is going from which group to which group? Going from what group to what group? Which one to which one? What's the starting one? Group number 1. Sure, check once again. Checked. Still 1. No. Yes, still 1. Yes. I didn't say no. I said you just check. For your confidence. It's going from group number 1 to something. What's the last number? You all find. ඔක්කොමලා හොයාගන්න ඕනේ. Remember now itself. Group number 1 to group number. What else without 8? Ne? No. Sometimes it's not 8 in some graphs. But this graph it is 8. It is group number 8. 1 to 8. And then you have to remember either this point and this point, or this point and this point. The turning points actually. Let's remember this one and this one, not these. Now you find, don't tell me, because I want everyone to find it. Find what is this group, what is this group. You find, don't tell others. තමුන්ගේ ඔලුවට ගන්න. හොයාගන්න. What these 2 groups are. And remember. Found? What is this group? What is this drop? Where is it? What is this group? Group number? Tell me now. 3. Sure? Yes. Yes. Group number 3. 3 down. And what is this drop? Group number 6. Sure? Check it. 604. VIOIV. You know, after school sometimes like you see 4 like 6, 6 like 4. Yeah, what is it? 6. Sure? Yes, 6. ඉස්කෝලෙන් පස්සේ එහෙම තමයි නේ. 6 එක 4 වෙලා පේනවා, 4 එක 6 වෙලා පේනවා. හරි. Right. Now remember, this is our structural units. Going from 1 to 8, third one but down, sixth one down. Okay. Now we are going to draw this one twice there. Twice there. Right? So quickly you can draw this one on left hand side or right hand side or somewhere. Draw this one and mark. It is going from 1 to 8, but third one is down unexpectedly, sixth one also down. 30 seconds only. Then ඉරි ගහන්න හැම නෑ ඔය වෙලාව අරගෙන මේක ඇඳ ගන්න. මෙයා වැඳ ගන්න. එළිය not inside the graph, outside the graph. This is the gadget. This gadget we are going to draw twice. It's okay now, use the term gadget. කමන්නේ නැහැ ගැජට් එක කිව්වට ඕන් ඔය ගැජට් එක දෙපාරක් අනින්න තියෙනවා. ගැජට් එක ඉස්සෙල්ලා ඇඳ ගන්න හරියට. අයියෝ like dead people පොඩ්ඩක් පණේ දුවනින්නෝ. Are you okay? Fit? Right, this is the gadget. Okay, these are the turning points. Now very important. Once again, focus on this. Keep your pencils, pens, whatever. Come on. Your writing machines. Keep. Writing. Come on. Look at this. Right. Okay, hari. Ahagando ne. Then we are going to draw this gadget there. Tell me, what's the starting atomic number? Can we draw this from atomic number 1? It's from group number 1. What are the atomic numbers of group number 1? Atomic number 1, group number 1. Once again, atomic number 3, group number 1. Atomic number 11, group number 1. Atomic number 19, group number 1. Yeah, tell me, can we start this from atomic number 1? No, because there are no 8 elements. From which one are there 8? From third one we can. So if we start from here, can't. From this one can. So let's go and start from third one. And if it is 3, what is the last one? That means group number 8. It is the 10th one. So 3 to 10 we are going to draw this. So I wanted to take another color and mark like this. Then it's very simple. We are going to go from 3 to 10. And sorry, one thing I missed. You should write here atomic number. Atomic number. Please do only what I say. Don't miss what I described. හරිද? පරණේව ඇඳ ඇඳ දැන් වෙලාව නාස්ති කරන්න එපා. ඔලුවට ගන්න. ඔලුවටයි ඕනි. හරිද? නෝට් එක පුළුවන් කොපි කරගන්න පස්සේ හරි වෙලාවක. හරිද? Mark the 3 to 10. Okay, now stop once again. Stop once again. 3 to 10. Right. Here we are going to start. This gadget we are going to put into this one. Right. It is going to go from 3 to 10. And what's the level? Here. Here. Okay. Say 1, 2, 3, 4. Which point? We have to find that. So let's divide this into about 1/3. We are not marking with these values now. We are unable to mark everything with these values practically correctly, impossible. So don't worry about that one. First you get practice how to do this one. Then if you want, you can find exactly starting from which value. As a start, we divide this into 3. 1, 2, 3 and we start from like 1/3. Right? Let's divide into about 3 and let's start from about 1/3. මේ වගේ තැනකින් පටන් ගමු. තුනකට විතර බෙදලා මේ වගේ තැනකින්. Right? So you also should do this one. Divide this approximately into 3. 1, 2, 3 and let's start this from about 1/3. Right? Mark 3 and 10 using another color, maybe larger, and put the first dot for lithium. Approximately divide හරියටම එපා. 3න් එකක් විතර අරගෙන මාක් කරන්නකො. dot එකක් දාන්න. Right, this is lithium. Now look at this. Look at this, look at this, look at this. Right, look at this, look at this, look at this. Now that one we are going to draw. When we draw that one, some of you, especially those who are sleeping, will draw like this. It is down. මනින්ද ගිහලා වැටිලා වගේ. හරි? And very active students will draw it like this. That also is bad. It should be in between. Right? This one should be parallel to each other. These two should be parallel to each other. It should be nice. So that's why we need practice to draw this one. Practice, right? So I try to draw it. Just look at this. 1 to 2 going up. So it is like this, 1 to 2 going up. Third one down. Down means this much? No, not that much. Little down like here. මෙච්චර පල්ලෙහාට වෙරෙන්න බෑනේ මේ හරිය. Okay, so I mark it somewhere here. Third one. Then I draw. Okay? Can you follow me and draw second one and third one? Not all, just second one and third one. Come on, draw. First to second, second to third. මේකට වැඩිය බය වෙන්න එපා. හරිද? එයා අපිටයි බය වෙන්න ඕන. අපි යාර නෙවෙයි. Right? Okay. Don't draw everything, just second one and third one. Now look at this again. After third one, up to fifth one going up. Right? This is sixth no. So 4 and 5 should be up. So we are going to draw another line parallel to this. This way we are going to draw another line parallel to this. Or you can take like 45 degrees here or 50 degrees here all the time. You can draw like this. Okay, you draw parallel to this, 2 more. Then 6th one, once again little down, draw like this. These points you can note as your private notes. If you want to note something, you can note. Harida, these are methods, no? By drawing can practice but can forget, no? තමුන්ට ඕන දෙයක් චෝටි නෝට් එකක් විදිහට දාගන්න ඔය මම කියන ඕන දේවල්. හරි? Right. Then 6th one down. After 6th one what? 7 and 8. Let's take a line parallel to this way, and let's mark 7 and 8. 7 and 8. This way you can complete your first gadget. You can put your first gadget into this approximately. So I told you I am training you because they are giving some segments of this graph. If you know everything, easily you can match it, fit it at the right place. Got it? Right. Now time enough. Once again stop. Now in your one I can see lines are not parallel. Please look at you all. You also may. This one and this one and this one should be maybe in my one not very parallel, but you can draw parallel. No? හරිද ඔය lines ටික මෙහෙම එකට එකක් parallel වෙන්න ලස්සනට ගන්න. No, especially you can erase your last one, and last one is spoiling your graph. last part, last segment අන්තිමට ඇඳලා නේද ඔයා කොටසක්. ඒක කෙලින් උඩට ඇඳලා තියෙන්නේ. Can you please help her? Can you please help her? The last part. Yeah, that part. Erase that one and draw again. හරි. බය වෙන්න එපා. අන්තිම එක තමයි වැඩි කාලා තියෙන්නේ. Okay, right. Okay, then we are going to put this gadget once again for the second time. Say we are going to copy this and paste, but where to copy paste? Here, little up, little down, where? We have to find it. And when we draw this for the second time, what is the starting point? Exactly here, up, down, where? We have to find. Right. This is how we find. On a stop your work and look at this. When we draw this once again, what is our starting atomic number? Once again, group 1. Our next group 1 is on atomic number 11. So we come to atomic number 11. We are going to draw our second one from 11 to what? You can use another color and mark like what I do. 11 to, yes, 18, no, 18. 11 to 18, we are going to draw this one. 11 to 18. We are going to draw this from 11 to 18. Going to go from 11 to 18. Right? Please mark 11 to 18. And don't draw. I am going to draw, then you follow. After practicing, you can be better than me even. Faster than me. Correct than me. But I have to support first. Right. Did you mark 11 and 18? Enough. Now look at this. Hari. Then balaganna me patta. Another karna. Stop. Here. Right. Hari. Now where's your hand? Alright, hand is there. No? Samarungi. I can't find where the hand is. Hari, hand එක හොයාගන්න කොහෙද තියෙන්නේ. හරිද? Okay? Right. මේ බලන්න. Now vertical starting line is this for sure, and horizontal line is what? Horizontal line is what? That means our initial one, our lithium was here. Where is next one? Sodium. You know, lithium to sodium, down a group, what happens to ionization energy first? Left to right increasing, top to bottom decreasing. So second one should be lower than this. Okay, this way increasing, this way decreasing. ඊළඟයා මීට වැඩිය අඩු වෙන්න ඕන. එහෙනම් so we take this level and next one is starting from 11. Where to mark here? Okay, let's take a point like this so that potassium can be taken somewhere here. Got it? Keeping a space for potassium, you take it little down and mark somewhere here. Next one. I told you, no, values you can consider later. First you get this one. හරිද? values දාලා අඳින්න ඕන නම් වෙනම practice කරන්න ඉස්සෙල්ලා අඳින්න පුරුදු වෙන්න. Got it? Level is low. If I put values here, no one can understand. No one can follow. Got it? Now, look at this, come on. Our first one was this black one. Our first one was this. Our first step. මේවන් අපි mark කරනවා steps. Our first step is this. Drawing this gadget. What was our second step? Our second step was taking this level left, right, number 2. So I wanted to draw an arrow like this and put number 1 and number 2. Then we can draw third one. Please put these numbers, you can follow later. Come on, 40 minutes only. ගොඩක් වැඩ කරන්න කිව්වේ නෑනේ. number 1 කියලා දැම්ම, arrow එකක් දැම්ම, number 2 දැම්ම. ආයෙ මන් දිහා බැලුවා. එච්චරයි. Okay. Going to die. Going to die. නෑ. පුළුවන් තා පොඩ්ඩක් අල්ලන් ඉන්න. After school I know very difficult. Right. Okay. Right. Now our third ones, these gadgets starting point is this. Got it? This one. The line is going little up, no? What to do? No graph papers, no square rule papers. Easily I can print graph paper on your tute. But I have to train you this way to draw without any help like that. Right. Hurry. Now once again we are going to draw this gadget. Look at this. I use another color, blue color this time. You also can do the same. Look at this. Same thing. 1 to 2 up, third one down. We draw this way. 1 to 2 up, third one down. And then don't ask me whether this should be above this line or below. Don't consider those things. You will never draw this graph then. Got it? ඔච්චර සියුම් හිතන්න යන්න එපා. හඳින්න බැරි වෙයි graph එක. Got it? Right. 1 to 2 up, next one down. Okay? Okay. Follow it, draw it. Then can you complete that gadget completely? Steps completely. පුළුවන්ද තනියම අඳින්න? Exactly same thing you have to draw there. Can you? Can you? Right. So 1 and 2, then third one down, then 4 and 5 once again up like this. 4 and 5. Then 6 1 down again. 7 and 8 again going up. 7 and 8 again going up. This is our number 3. Please put number 3 there. Come on, draw up to 8. I want to see some of your diagrams. Okay. I wanted to find one mistake, but I couldn't find it. That means you are really good. I wanted to find something, right? Wrong. I couldn't find. Very good. what I wanted to find was this. Okay, exactly like this line, if you draw another line to mark that level, neon's level, argon should be lower than that, and you got it that way, correct. I wanted to see argon up here, I couldn't. තේරුණාද? සමහර මං හිතුවා මීටත් වැඩි උල්ටන් දී කියලා. ඇඳලා නැහැ. හොඳයි ඒ කියන්නේ. හරි. මෙහෙම if you take a line, this should be lower than that. Got it? Right. It came that way, right? Okay. Now complete. Once again, to get potassium and calcium, from this we have to go right. Did you put number 3 here? Same as number 2, from this we go right. We go right from this. And what is our next atomic number? 19. Until we meet 19, we go this way. And yes, we met 19 here. And tell me, where is the place for potassium? Here? No. Up? No. Down? Yes. So let's take somewhere potassium and calcium. Draw that. Number 4, this one, and draw in that part. Now at least you have some steps to follow, isn't it? If you say forgot everything, you know from where to start now. Number 1, that's good. Right, enough. 2 more, hydrogen and helium. Okay, we look at this then. Look at this, please look at this. It's time to put the last part into your head now. Right, hurry. ඔන්න දැන් ඔලුවට දාගමු. Right, hurry. Right. All look at me. Right. Hydrogen and helium. Hydrogen, helium. There's a way to find hydrogen, there's a way to find helium also. You tell me which one first. Hydrogen or helium? Someone tell me. කියන්න බය වෙන්න එපා. හරි, hydrogen. Let's say hydrogen. Right. There's a separate way to find hydrogen, separate way to find helium. Hydrogen. Hydrogen you can find this way. You find, okay. You tell me. Hurry, you find. If I give, it's bad, no. This hydrogen is in equal level with someone else. Go and find who is that. Hydrogen's position is equal to another one close by. Who's that? You find. You find. Then you can understand. What is it? Oxygen. Oxygen. Sure? Ah, yes. Then yes. Yeah, you have to have that confidence. Sorry. Oxygen's level. So you go and find oxygen. Where's oxygen? Oxygen is our 8th element, and this is 3rd one. 3, 4, 5, 6, 7, 8. If you find 8, oxygen is there. So this oxygen's level you mark this way. Approximately you can find the place of hydrogen. Please look at this. From oxygen we are coming towards left, so you have to put this arrowhead. Exam day don't put these arrowheads and all. This is our say 5th one. Number 5, we come from oxygen. I mark oxygen here. Left. Atomic number 1, oxygen's level. You can find hydrogen. I told you can make some private notes. Notes ලියා ගන්න පුළුවන්. කැමති ඒවට. You take oxygen's level, you can find hydrogen. I know in my graph it's not, these are not parallel. Hydrogen should be little up, but you can draw correctly. You have vertical lines and horizontal also. Got it? Right. Where to mark the helium then? Think this way. Look at this. This is argon. This is neon. And where is helium? Helium to neon, neon to argon, first ionization energy is increasing. What increasing? Increasing or decreasing? Helium to neon, neon to argon, ionization energy decreasing. So, argon to helium increasing. See, argon is here, neon's level is upper, above than that. Ne? Okay, let's start a line from here and go and get helium's place. Helium is here. Got it now? That level should be above this, right? Upper level. Simple. So, let's put an arrowhead this way. Argon to neon, neon to helium, value should be increasing. Let's put number 6 here. We can get helium here. Helium here. I didn't mark symbols of elements because if I mark all the symbols here, you can't see what I do. So, you also don't put symbols here. Exam day you put. Okay, today don't put. හරිද මම සිම්බල්ස් ඔක්කොම දැම්මම නම් මෙලෝඩියක් පේන්නේ නැහැ. ඒකයි සිම්බල්ස් වැඩි දැම්මේ නැත්තේ. එක්සෑම් දවසේ ඕගොල්ලෝ දාන්න අද දාන්න එපා. Got it? Right. Now the last step, connecting them together. Connecting them together. I am going to use blue, green color for that. Come on, look at me. Look at this. Look at this. Right. බලන්න මේ පැත්ත. Argon and potassium we can connect this way. You can take your ruler and you can connect. Right. These two also we connect now. You take your ruler and you can connect. You can use a different color even and connect these two also. Helium and lithium and hydrogen helium using maybe blue color. You can connect. You can get your nice graph here. So, please put numbers, arrowhead directions. Sorry I missed one arrowhead here. You know the point number, you know the direction to go. You can find it. First ionization energy kilojoules per mole, atomic number. After practicing this, even you can draw with y-axis ionization energy values, isn't it? Yeah. If you can draw this, then you can draw with values, but I don't think that you need with values. Got it? දැන් ඔහොම අඳින්න පුළුවන් නම් values ටික දාගෙන අඳින්න බැරිද? nothing එක. එහෙම එච්චර practice කරන්න එපා. මෙහෙම practice කරන්න. Right. So exam day when you are getting a segment of this, can you fit it with this graph? Can, because you know the whole graph. Maybe from oxygen to magnesium, a small segment like this can come. නිකම් මේ වගේ පොඩි part එකක් අරගෙන මෙහෙන් දෙන්න පුළුවන්. ඒක දැන් අපිට high කරගන්න පුළුවන් මේකට. Right. Shall I erase this one now? Erase this one. මෙච්චර මහන්සියෙන් ඇඳපු එක. ඔව් තව එකක් තියෙනවා නේද? 30 minutes තියෙනවා. 25 minutes to draw electronegativity one. Electronegativity one is cool. Not that difficult. And with this practice training you can draw that one. You are thinking, no, what a graph. Okay. Right. Okay. You are not okay now after drawing graph. Looks nice. Better now. නේද graph එක ඇඳලා ඔස්සේ පණ ඇවිල්ලා සමහරවිට හරි වැඩේ හරි. Right. Electronegativity graph is this. Come on, complete. Sorry. First ionization energy graph is this. Let's draw electronegativity. But taking 5-10 minutes, I have to introduce you what electronegativity is. That's the thing. What electronegativity is. Okay, please check these things once again. Atomic number, you wrote atomic number, 2 words. Put atomic numbers 1 to 20. Okay, yes. You wrote first ionization energy and inside brackets kilojoules per mole. You put atomic numbers 120, yes. Then did you mark these steps 1, 2, 3, 4, 5, 6? So following these steps you can redraw this easily. And did you mark arrows directions? You work from that to this. that to this, but here left towards left. Harida? Okay. So please draw today itself again and again about 2 times and get more practice and speed also. Right? Day after tomorrow වගේ වෙද්දී ඕක අමතක වෙලා දී ඔක්කොම අදම පුළුවන් නම් අදින්න. Right. Now we come to electronegativity. Electronegativity. විද්‍යුත් ඍණතාවය, electronegativity. What is this electronegativity? Once again I have to come to grade 10 unit 10 to describe you electronegativity, polarity and all. Right, can find some more energy කොහේ හරි energy ටිකක් හොයාගත්තා ඇති කොහේ හරි තියෙනවා ඇදලා ගන්න කකුලෙන් හරි කොහෙන් හරි need some energy. You are going to die. Still thinking about that graph, ne? Don't worry. If you have doubts after class, come and ask. Okay, if you have any doubts about this. So you have to put symbols of all the elements. You have to do later. And exam day you don't draw these dotted lines, arrows. Don't put those things. Hurry. Your last answer should be like this printed on exam day. But y-axis values won't be necessary. ඔයාලා විභාග දවසේ යන දිනේ කොයි print කරපු එක වගේ වෙන්න ඕනේ. values නම් ඕන වෙන එකක් නැහැ. Now electronegativity. Okay. Ready? Electronegativity. This electronegativity comes at the end of a story. At the end of a story, electronegativity is coming. So we have to learn the story first, and this is from unit 10, chemical bonds. Helium, neon, argon, outermost shell is full, no? They don't form chemical bonds, I told you. Almost all the other atoms form chemical bonds, I told you. Right? When hydrogen and chlorine meet together, they form a nice bond. When hydrogen and chlorine met together, they form a very nice bond, which we discuss in unit 10 also, now also. When hydrogen and oxygen meet also to form water, they do the same. Right, let's take hydrogen and chlorine, because water is H2O, 3 atoms are there. Hydrogen and chlorine, HCl. Your school lab has HCl, isn't it? No school lab? No HCl there. School lab එකේ hydrochloric acid ඇති HCl කියලා there. Now we are talking about that hydrogen chloride. So when hydrogen meets chlorine, let's draw hydrogen quickly. Hydrogen is the first element. It has 1 electron here. I show electron by a dot here. Chlorine. Chlorine is 17. 2, 8, 7 electrons in the outermost shell. 7 electrons in the outermost shell. So I draw chlorine. Don't think about the size. I just draw chlorine this way. 7 electrons are there in the outermost shell. I can use crosses this time instead of dots. These electrons. Grade 10 unit 10. First atom's electrons by dots, second atom's electrons by crosses we can draw. When they meet together, hydrogen will ask chlorine. Chlorine, there are 7 electrons in the outermost shell. Can't you give me one? Just one. ඔයාට හතක්ම තියෙනවනේ. එකක්වත් මට දෙන්න පුළුවන්ද කියලා අහයි. Why? Hydrogen will say, I want to become like helium in electronic configuration. I need one. Can you give me one? What would chlorine say? Will chlorine say, I give you one? No. Chlorine says, yeah, I have 7, but same problem for me also. I want to become like argon. I want to get 8 electrons into my outermost shell. So you have 1 electron more, 1 electron no, you give that electron because I want it. Will hydrogen say, okay, I give my electron, you take it, you become stable. Okay, you live happy life, you marry someone, I die, it's okay, I give my electron. Both need electrons. Then they find a solution. This solution is sharing this electron with this electron. Hydrogen and chlorine start to share this electron with that electron. You know, if you want to say, when you draw these graphs, I ask you to bring some color pencil. Say you brought only one, your black pencil, and your friend has a color pencil. So if you share your pencil with your friend's pencil, both can use both colors, isn't it? So by sharing, we can get something. So hydrogen and chlorine start to share one electron in between them. Why one electron? Chlorine needs one, hydrogen also needs one. So they come to an agreement. Listen carefully. Hydrogen and chlorine come to an agreement. What is it? Hydrogen keeps its electron here in between hydrogen and chlorine. Chlorine keeps this electron here in between hydrogen and chlorine. Then their agreement is to share these two electrons, right? Other than this electron, chlorine has 6 more electrons around it. This way we show. These are called Lewis dot cross diagrams in unit 10. Hurry, Lewis dot cross diagrams. So what do we really need here? This one. Hydrogen and chlorine start to share these electrons. Then both are happy. Hydrogen can use 2 electrons. Hydrogen can feel 2 electrons in the shell. Chlorine can feel 2, 4, 6, 8 electrons. Both are stable now. So hydrogen chloride is a good couple, stable couple, right? Soon after forming this chemical bond, chlorine starts to do something really bad. What is it? Breaking the agreement, negotiation. Chlorine attracts both electrons towards it. Ne? හරි අපි ෂෙයා කරගමු මැදින් තියාගමු කියලා පටන් ගත්තා. දැන් මෙන්න මේක ඉලෙක්ට්‍රෝන්ස් දෙකම උගේ පැත්තට අදිනවා. Hydrogen can feel this. Hydrogen wants to stop it. Hydrogen tries to pull electrons but can't. Why? Chlorine's electron attraction ability is much stronger than that of hydrogen. This electron attraction ability of a chemical bond towards itself is called electronegativity. We came to the point. So what is electronegativity? Ability of an atom to attract electrons of a chemical bond towards itself when it has a bond with a different element. Come on, few more minutes. So what is electronegativity? Ability of an atom to attract electrons of a chemical bond towards itself when it has a bond with another different element. This electron attraction ability is called electronegativity. හරිද? atom එක වෙනත් element එක්ක atom එකක් එක්ක bond එකක් හදපු වෙලාවට ඒ bond එකේ තියෙන electrons දෙකම තමුන්ගේ පැත්තට ඇදලා ගන්න පුළුවන් හැකියාවට කියනවා electronegativity. Got it? Electronegativity. So our topic is not actually what is electronegativity. Our topic is how does this vary from left to right and top to bottom. Got it? Now you know what electronegativity is. So without taking time for electronegativity, we are going to draw this one. Okay, we take 2 minutes and read this one. If there is something to write, we skip. Next day we write. Come on, Nanny. අපි විනාඩියක් කරන් මේක කියවමු. මොන හරි දෙයක් අඳින්න තිබ්බොත් ඊළඟ දවසේ ඒක අපි draw කරමු ඈ. Right. Electronegativity. Ready? Page 9. Two atoms form covalent bonds between them by sharing valence electrons. These are called covalent bonds. Our syllabus has ionic bonds, positive negative ions make those bonds, and covalent bonds. Atoms by sharing electrons, these bonds are made. Certain atoms attract these bonding electrons without keeping in the middle of them. Draw. We draw it next day or today after finishing the graph. Right? Right. Example. Example also we skip. We have another example. Electronegativity is. In this definition, I have cut and removed 3 words. Why? Because of these 3 words, sometimes you are unable to remember this one. So when we cut those 3 words, you can easily remember and you will get full marks also. Right? So first you remember without these 3 words. What is it? The ability of an atom, of an element. So when you try to remember this one, the ability of an atom, of an element, sometimes you get confused. Sometimes you write the other way. The ability of an element of an atom, and something in there. of an element, of an atom, of an atom, of an element. ඕක හිතේ තියෙනවා. එකක් අයින් කරාම ලේසි. හරි? Then it's the ability of an atom to what? Attract electrons of a chemical bond towards itself. So right there, to attract electrons. Come on, right there, fast. To attract. Attack නෙවෙයි, not attack, heart attack නෙවෙයි, attract, ආකර්ෂණය. To attract electrons. To attract electrons. Right? Of a bond towards itself. Itself. Towards itself. Right? When it is bonded to an atom of another element. Right? Right. Now you know what to do. We take the table and we understand the pattern. Right. Left to right, hydrogen 2.1, helium missing. Why? Okay, we go to next period. Lithium to beryllium 1.0, 1.5 increasing. Next one 2 increasing, then 2.5, 3, 3.5, 4 increasing. Last one again missing. What is electronegativity? Ability to attract electrons of a chemical bond. You know, helium neon argon are not going to make bonds. If they don't form bonds, we can't talk about bond electrons. Can we talk about divorce of a person? Unmarried person. Can we talk about divorce of an unmarried person? First person has to marry, then we can talk about divorce. Like first marriage, divorce, second marriage, divorce, third marriage, like first ionization energy, second ionization energy, third like that. So not applicable at all here. Got it? That's a bad example. First marriage එහෙම ගන්න මම නිකන් කිව්වේ. මේ තේරුණාද? Can we talk about first time electronegativity of a noble gas? No. Why? They don't form chemical bonds. And remember, no chemical bonds, no electronegativity. If you don't know this one, exam day you will be finding electronegativity of noble gases. Why? Go. Noble gas is not here. You will mark noble gas somewhere in the graph. Completely wrong. Remember, noble gases are not in this graph. Got it? Remember, I told you when we were drawing this, sometimes graphs are not going up to 8. This graph is not going up to 8. 8 is not here. තේරුණාද? 8 වෙනියෙක් නෑ මේ graph එකේ. 7යි ඉන්නේ. Right. So left to right increasing or not? Increasing. Continuously increasing? Continuously increasing. Is there any drop? No drop at all. Therefore our lines are smooth. Our lines are smooth, not like a ladder, not like a staircase. Right. Top to bottom, hydrogen 2.1, lithium 1, sodium 0.9, potassium 0.8. Decreasing or not? Decreasing. Pattern is very clear. Left to right electronegativity increases. Top to bottom electronegativity decreases. Exactly like last time, but this time graphs are very smooth. Ready? Right. What is the unit of electronegativity? No unit marked here. Read the two lines below the table. Pauling electronegativity values of the element with atomic number 1 to 10. 1 to 20. So these numbers are 2.1 and all are which numbers? Pauling values. I wanted to highlight Pauling electronegativity values. There is no unit, there is a scale. You know earthquakes are measured in which scale? Pauling scale? No. Earthquakes are measured in which scale? Richter scale. ඔය තියෙන්නේ ඔය වගේ තමයි Pauling scale. And don't say earthquakes are measured in Pauling scale. No, it's a Richter scale. Electronegativity, Pauling scale. උරිස්සේ ඔළුවක් තියාගෙන ඉන්නවා පව් අප්පා. තව විනාඩි 10යි කොහොම හරි ඉන්න. After school I know very difficult what to do. Right there. So what is this name? Pauling scale. Now cut and remove table. We are not going to remember tables values. We just use. Right. Let's answer two questions. Pattern of variation along periods from left to right. Yeah, what to write? Along periods from left to right. No, but can't open mouth. No energy. Cut araganna palme. Right. Left to right. Right there increases. left to right increases, sure. Then along groups from top to bottom, what happens? Decreases. Hari? Electronegativity decreases. Nathang electronegativity is decreases. Now our graph, right? We have only 10 minutes. 8 minutes actually. Hari 10 විතර ගමු අපි. 10 12 ගමු. ඔන්න එහෙනම් you know, on the next page there is a question number 3. We do it another day. Now we draw our graph. So quickly I want you to do the same. Draw y-axis and write electronegativity. Draw x-axis, 20 numbers quickly, and draw dotted lines. You have to do in 2-3 minutes. Now you got the training, you know what to do. විනාඩි 2-3න් කරන්න ඕනේ. හරි ඉක්මනට කරමු. y axis එකේ ඉඳලා electronegativity කියලා ලියන්න, x axis ඉඳලා atomic number කියලා ලියන්න. dotted lines ටිකක් ඉක්මනට අඳින්න, vertical lines. You know, when we draw 2 graphs same day, you can get it very easily. Same day. නේද? එකම දවසේ මේ දෙකම කරාම තමයි ප්‍රැක්ටිස් එක හොඳට එන්නේ. අපි එහෙම කරමු අද. So please work your fastest vertical lines. වැඩි හිතන්න එපා, ඉක්මනට අදින්න. Remember today අපි 3 to 5 කියලානේ කිව්වේ. If it's very difficult to come by 3, then tell me, then we can like start around 3-5 to 5-5, right? කාටරි ගොඩක් එන්න බැරි නම් පොඩ්ඩක් කියන්න. ඉතින් 3-5 වගේ කරන්නත් පුළුවන්. Okay, right here electronegativity. Now you can understand why I skipped noble gas not T1. Ne? Right, atomic number. දැන් තේරෙනවා ඇති වෙයි මම අර චූටි ටොපික්ස් ටික අතහැරිය කියලා. අතහැරිය නැත්නම් දැනටම වෙලා ඉවරයි. Okay, I know maybe time is not enough, but සමහර අය නම් ඉවරයි දැනටම. නියමයි. Right. පොඩ්ඩක් බලන්න එහෙනම් දැන්. චොට්ටක් බලමු. පොඩ නවත්තමු අපි. Right. Come on. Right. Please stop all. Right. තියදී පොඩ්ඩක් නවත්තමු. Right. Okay. Ready? Maybe look at this. Come on. Drawing is not the most important thing. Taking head is the most important thing. This time, when you look at this printed graph, lithium to fluorine, sodium to chlorine, same or not? Look at the shapes. Same shape or not? Same or not? Last time same shape. This time same or not? Not same name. Open your eyes well and see. Can't you recognize their difference? Now can. What is it? This is important. One is not 100% straight, but looks straight. Second one is little curved like this, not this much. I wanted to show it well, that's why I drew this way. Now can you identify the difference? Yes. බලන්න තේරෙන්නේ නැත්තම්. Exam paper will give you this one or this one and will ask you to recognize as lithium to fluorine or sodium to chlorine. Now can you see the difference? Yes. මෙයා දෙයිද දන්නේ කවුරු දුන්නත් පුළුවන් වෙන්න ඕන. Right? Going from group number 1 to lithium to, yes, group number 7 this time. Helium, neon, argon not present here. Got it? This also is going from group number 1 to group number 7, not 8, 7. Got it? Right. What is the starting atomic number of this? You know it is 3. So I mark here 3 this way. Balanginde. It is going to go to group number 7. That means fluorine. What is atomic number? 9. Atomic number 9. So I write 9 and 3 this way, going from 3 to 9. Got it? Exactly like last time, we don't take y-axis. This time we do it little better. Look at your printed one's y-axis. Electronegativity, there are only 4 values. What are they? 1, 2, 3, 4. Hari. 1, 2, 3, 4 we can mark correctly. 1, balanginde, 2, 3, 4. Now tell me, lithium's value is how much? Please use the table. Lithium is how much? 1.0. Exactly from 1, this is our number 1. May balanna? This is our number 1. We are coming from 1 and we get lithium this time. And what is the last one? Fluorine. What is the value in the table? 4.0. So our second step is, now you have this practice, so you can do this fast. I know. You also know. Number 2, from 4 we go right and we get this one. Got it? Then we just using our free hand, we connect them as a straight line. Hurry. Mark this. From 1, number 1, from 4, number 2, we draw our line. Very right. Very simple. We started 5 minutes late because of late comers. Now it's 4:59. Hari, the step 1, we come from 1. We come from 1 towards right. Please mark these arrows. Step 2, we come from 4 right. Number 3, we connect them. That's our first step. Easy. Please mark these 3 and 9. Okay. What is our next starting atomic number? Is that 10? 10 is what? Neon. Noble gases are not here. Neon is not in this graph. Our next one is sodium. Sodium's atomic number is 11. So from 11 we start. Please mark it nicely. 11 is our starting one. අපේ ඊළඟ එක පටන් ගන්න 10 වලින් නෙවෙයි 11 වලින්. And going up to 17 chlorine. 17 chlorine. How can we get the starting point? Exactly like last time, we can go from lithium towards right. And if you check the table, sodium is of course less than this. How much is it? 0.9. So let's take a little below this one. We get it. 0.9. This is our fourth one. We go right from this. 0.9. අරයට වැඩයි පොඩ්ඩක් පල්ලෙහා ඉන්නේ. ටේබල් එක හොරෙන් බැලුවොත් එහෙම 0.9. ගොඩක් පල්ලෙහාට ගන්න එපා. Right. Last one then, how can we find last one? Last one should be little less than this, lower than this. If you check chlorine, how much is it? හොරෙන් බලන්න කීයද? 3.0. Ne? Chlorine is 3.0. So from 3 we can count. මේ පාර හරි ලස්සනයි. 1, 3, 4 we are using. 1, 3, 4. We can draw much accurate one. right. This way go towards right. This is our fifth one. හරියටම number 3 වලින් 3.0 වලින් එනවා දකුණු පැත්තට. Fifth one 0.5. 0.5. You know, you can watch this one class once again. After uploading, I'll send you link. It's really important. Right. From third one, we come towards right. We find the position of chlorine. Position of chlorine. Then when we connect them together, we have to use that slightly curved one. This way you should curve it and curve little. I have to curve little more because otherwise from distance you can't see. ඈතට පේන්නේ. ඒ නිසා මෙහෙම ඇඳා. ටිකක් වැඩිපුර So students here front, don't curve it more. අරගොල්ලන්ට පේන්නේ වැඩිපුර curve කරාම මේගොල්ලෝ තවත් වැඩි කරයිද දන්නේ. Easy, right? Yes. This time we have values. From 1 we go, from 4 we go, then from 3 we come towards right. Okay. Now very few more. Right. We have to find potassium 0.8. This was 0.9. That one is 0.8. So we come from this. And what's the atomic number? 19. Our next one is 19. Right. This way we come. We mark little below that one. And then next one is, see, calcium is exactly 1. Don't consider those things. Just draw like this. අපි ඔය ඉච්චර ගණන් ගත්තේ නෑනේ. Calcium 1. Right. Then only one more thing. Okay, sorry, what's the number here? This is 6 and then this is 7. Right, what's the last one? Hydrogen. You find hydrogen from the table 2.1. So we didn't use 2, no? Now you can use 2, but not 2.1. Okay, not 2.1 for hydrogen. And this is our last number 8. On 8. We come from 2 right and we mark 2.1. This is our 8, hydrogen. I didn't do very fast, but I did little fast, but you know, you can use this video once again if you missed something. Our last step, connecting these together. This one and this one, and this one and this one. So we draw this graph with values because it's very easy. Last one we draw without values. Our electronegativity graph. Sometimes I take a photo of this and send you, but here you are going to get the recording, so I don't have to take a photo here. Right there. So as I told you, I want you to practice this today if you can, or get this video and practice. I have to get the recording from them and we can upload later. Okay, so first ionization, energy and electronegativity, both graphs we finished. All the theory parts also we discussed. 2 questions I skipped. They are not from the textbook but from chemistry. Last week we finish everything. And we start your TOTS part 2. Right? Part 2. So what I told was correct, ne? So without my help, difficult to draw these graphs, right? But now, did you mark all these steps? Then it's simple. And this one is going from left to right, you know. Left to right, left to right, left to right, left to right. Okay, so please draw this and get your speed. Exam, most probably won't give everything, will give you short part, small part, maybe like this. Something like this. Okay, something like this. Then you have to find what is this one, what is this one, what are these. Now you can, because you know the whole picture now. Okay, right. Then let's stop this class here. Next day, first we finish what we missed today and we continue. Right? Okay. Right? Okay then. See you next time. If you have doubts, bring. I am ready.